we're going to present you our report for the final project of the Lab in Data Science course, which was about building robust journey planning, and we are the Selecta team. Just to sum up about this whole project, we were asked to build a journey planning which would take into account the risk factor of trips to be delayed. So we were asked not only to find an optimal solution in terms of time to go from a point A to a point B, but we also had to optimize the certainty we had that this trip would not be delayed. The dataset we were given for this assignment was from the CFF company, it's a Swiss national train company. And we had information on every public transportation. So we restrained to an area of 10 kilometers around Zurich. And the data we were given was really station oriented, which means that every row on the database was about a station, and we had information about the schedule of the arrival and departure of every train on this station, and if and we also had information about the actual time of departure and arrival at the station. So the first action we had to do was to transform this into a timetable where we would have information for a typical day of every trains and hours in a more trip-oriented manner. So we made the assumption that we only had 3 different types of schedule. We would have a schedule for a regular weekday, and then a schedule for the Saturdays, and different schedules for the Sundays and the big holidays. Once we had these timetables were generated, we had to compute all of the delays on every trip, delays on departure and on arrival. And then we had to transform this into distribution probabilities. So we compute the probability distributions of arriving with a certain delay and of departs with a certain delay. And because our algorithm required it, we also had to compute the conditional probabilities, which means for every pair of station in the same line, we had to compute the probability of arriving with a certain delay, given that we were gone from our origin with a certain delay. And unfortunately, this ended up being quite costful, computationally speaking. And once we realized that the competition was going to be way too heavy for us to handle, we had already committed to our model, and we had no other choice but to stick to the choices that we made in the implementation. And therefore, to be able to show our results, to show our algorithms and to have visualization, we decided to spoof data, and we decided to spoof them from appropriated probability distributions.
So after getting this timetable, this distribution, and all the information from the link between station and trips, we apply a different algorithm to find the best solution for a planning problem. So firstly, we generate an action map that allows us to discretize the problem and avoid to apply stochastic calculus on the graph to explore it. So the BFS are used to find action to explore the node along the path, in the 2 ways. And we use also a DFS to select the node along the graph. The action map will generate action for each node. Each node has some information and link them to the line, to their neighbors, etc. All this information are then used in a routing algorithm that propagate certainty along the graph. We use the timestamp calculus, and at each node, we wait to have all the propagate at time t before propagate the next action at time t+1. and after all, we get the best solution without randomize the data. Regarding the displaying of our results, we use firstly a user interface that allows anybody to fill a form and generate a trip. So you can choose the date, the time, the departure, and the arrival. After this, we decided to plot our result into on a map. So we'll show you the first map that that displays the graph of all stations of train, buses, but also also the lines corresponding. We had just a point on this. We had a working time between stations under 5 minutes to get a better accuracy. So this is the form we generated for the user. And this is the action map plotting. So the red point is the start station, and we all the different possible trajectory. And finally, this is the result of our routing algorithms that predicts the best way to reach a 2 point. So we start at red point and we try to reach quickly the green point.
Okay, and so we have finally some advantages and drawback of our algorithm. The main advantage is that it is deterministic, which means that if you ask twice for exactly the same trick, you will have twice the same input, which is something necessary. And unfortunately, we have a big drawback, which is that our model is very heavy computationally, and it does not really apply to large and very connected networks as we have.